Hey everyone, it's Mr. B back with another video. This is lesson number 14, and as promised, I'm going back over lesson 13 so that way you know the answers to the questions that you had to do. So let's take a look. You were asked to read the graph and respond to the questions in the Google form. Of course, the Google form is right here, and let's take a look at what we should have for answers. All right, so magma varies in composition and is classified according to the amount of silica it contains. The graph shows the average composition of the two types of magma. Use the graph to answer the questions. Remember that the magma is the stuff that's inside of the earth, the molten material. And there's going to be two that we're looking at. The first one's called basalt forming magma, and the other one is called rhyolite forming magma. All right, so study both graphs. What materials make up both types of magma? All right, so we're looking for the stuff that's inside of there. And so we see that silica is one of those items, and we have other types of oxides, and we also have all other solids. Okay, so there's three things that make up this one. When we look over here at the rhyolite forming one, there's silica, other oxides, and all other oxides, so they're the same in both. So you should have those three things: silica, other oxides, and all other solids. Number two, which type of magma has more silica? And I know I busted these two questions into two separate questions, so this is number two that we're going through right now. The second part will be number three. So it says, which type of magma has more silica? When you look at this one, it's about halfway, making up the circle. And this one over here, if it's half, it would be right here. So it's slightly bigger than half. So we know this one has more silica. So for the first part of number two, or in your case, when you responded number two, the correct answer is rhyolite forming magma. The second part says, about how much silica does this type of magma contain? Well, let's just say that this one was 50% because it's about halfway right across there. And this one, if it was 3/4, would be right going about here. So it's slightly less than 3/4 or 75%. So I'd say it's about 70%. So for the second part of number two, or in your case, number three, the answer would be about 70%. If you're within kind of 5% there, you're good to go. Number three, this one was a little bit of a trickier question. It said a third type of magma has silica content that is halfway between that of the two types. How much silica does the magma contain? Well, if we said this one is about 50%, and we said this one is about 70%, if we average the two out to try to figure out where it would be, you take 70 and you take the 50, you add them together, and you end up getting 120. You divide by 2, and you end up getting 60. Or I'm sure you could come up with an easier way that 50 and 70, kind of that halfway point there in between them, would be the 60. So correct answer for number three would be about 60%. Okay, and obviously that's going to depend on what you came up for. If you put this as 50 and this is 70, so your answer might be within a range of 5 there. And then the last one says, what type of magma would have a higher viscosity? And then explain your answer. This is a tough question because the video touched on it a little bit, but not a lot. So if you struggle with this one, we'll go over it real quick here. So one thing that magma depends on in terms of higher viscosity is how much silica is present. And we know that when something has a higher viscosity, that is the resistance to the liquid flowing, right? So if you take water, you take honey, and you pour them together, or you pour them at the same time, obviously the water is going to move faster. The honey is going to go slower, and so we'd say that the honey has a higher viscosity. And what determines viscosity, or the resistance to flowing, or basically moving slower, is the amount of silica. And because of the fact that this one has more silica, it is going to move slower, or it's going to have a higher viscosity. And so the correct answer for number 4, what type of magma would have a higher viscosity? It's going to be the rhyolite forming magma. And the reason why is it because it contains more silica. All right, so if you struggle with number 4, now at least you have a better understanding of it. All right, in terms of today's assignment, you're going to watch the video. We're talking about volcanic eruptions, learning a little bit about what those are and what the impact is, and then respond to the questions in the Google form here. All right, so that's today's lesson. Hope everybody's doing all right, and we'll talk to you soon.